shall now describe how to create a missile trajectory model. Trajectory models. These are computer models that can be made to predict the trajectory or path of a missile, and these are done at certain angles and speeds, and depending on these angles and speed, the model will show a path that is longer or shorter. Constants that will not change. When you're entering them into a spreadsheet, these are entered near the top. The different kinds, one's a constant and it's t-step. And the meaning of this is time step. And the value of this can vary depending on what you want. And for this case, we're going to use a t-step value of 0.5. And basically this means that the missile's position will be calculated every t-step. So when t-step equals 0.5, we will be calculating the position at 0.5 seconds, 1 second, 1.5 seconds, 2 seconds, 2.5 seconds, and so on until it ends. Another constant is the angle, and this is the launch angle, and it changes, and just as an example, we're going to use 45-degree angle, and this is the angle in degrees at which the missile is launched, or the object. Another constant is v, which is the launch velocity, which for this is going to be 100, and the velocity is measured in minutes per second at which the missile is launched originally. And g is the force of gravity, and this has been rounded to -10, and this is the force of gravity acting on the Earth in meters per second, so it affects how far the object will travel through space. Variables. These are the things that will change when we're trying to figure out the trajectory of something. And if you're working in a spreadsheet, these go across the spreadsheet. And a variable t, the meaning is time, and basically it begins at 0 and increases every t-step. And then x is the horizontal position, and this is the position of the missile at a given time, and which correlates to this is y, which is the vertical position, which is also the position of the missile at a given time. How trajectory works. It's basically the motion of an object, and it is based on the acceleration of gravity, the launch speed, and the launch angle. And also it's important to note that a launch of 45 degrees gives the maximum range of an object. And here are different trajectories with different angles, and as you can see, the middle line, which is the blue one, which has an initial trajectory of 45 degrees, in fact does have the longest range. And depending on how you want your object to travel, you can vary the starting angle. For example, if you vary the starting angle to be 60 degrees, it'll have a higher max and go shorter distance than the 45 degrees. And likewise, if you want the starting angle to be, say, 30 degrees, it'll have a much lower maximum point that it reaches. How trajectory looks in action. Below is a little video of how different objects can travel through space. And as you can see, all lines have the same starting angles, but they have different starting velocities. So basically, the green line, as you can see, has the shortest distance traveled because it has the least amount of starting velocity. And then the blue line has a little bit more starting velocity, and the black line has the most amount of starting velocity, and so it goes the highest and the farthest. Have errors been made? Normally, these are human errors, and there are ways to check, and this can be to make sure that your graph is symmetrical around the curve and to review your inputs. Is the physics correct? The formulas can be rechecked from textbooks or other online information, but you need to remember that the formulas are used to simulate a missile or an object traveling through a vacuum. So they don't really calculate wind, temperature, altitude, air friction, or etc. Are the variables accurate? The rate of acceleration due to gravity is normally represented by 9.8. The effects of gravity can be factored by multiple variables, but they first have to be known, like their position on Earth. And here's my bibliography. As you can see, I used Informational Technology in a Global Society for the IB Diploma by Stuart Gray. And I also used a website, Hyperphysics.